In this episode, we're going to look at how to determine the DR and BDR. I'll show you how to do it, and we'll talk about the concepts along the way. We'll examine DR and BDR roles and watch the roles change when there's a change in the network. We'll then modify the priority to control the roles and force a new election. Finally, we'll verify routers are filling the desired roles. Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Determine the designated router and backup designated router. I had the Packet Tracer Lab open. On the left side, I have our work area where we have our topology and our devices. That's where we're going to do our configuration and verification when we're done. On the right side, I have our instructions. On the way bottom right, I have the actual Packet Tracer activity window that opens up when you open up your Packet Tracer file. Above that, the main area on the right side is the Word document of those same instructions. The reason I have the Word document is it allows me to answer the questions and save those answers in the Word document. We have, for our topology, we have 3 routers. Those 3 routers are connected to the switch. This makes it an OSPF multi-access network. These 3 routers are going to form adjacencies with each other and share LSAs. OSPF will go through the election process of establishing a designated router and a backup designated router to control the flow of those LSAs. We have our addressing table over here on the right side. We have 3 routers, we have the interfaces, we have their IP addresses and subnet masks that go with them. Down to our instructions. Part 1, examine the designated router and backup designated router changing roles. Wait until the amber link lights turn green. What that means is over here where you see all of my green triangles, when the lab first started and opened up, they were amber, or some people would call it orange, circles. That was the switch going through the negotiation. These connections down here were those amber circle dots, orange circle dots. We have to wait until the negotiation for speed and duplex and all that kind of fun stuff on the switch happens. And then once we have that, the election process can happen and we can get the designated router and backup designated router. Step 2, verify the current OSPF neighbor states. Use the appropriate command on each router to examine the current designated router and backup designated router. If a route shows full DR other or drother, it means that the router is not a designated router or backup designated router. And once again, this full drother, full DR, full BR means it has full communications. It has the full OSPF communication. So it's sending link state update or announcements. It's receiving those. It's asking for database, the database packets. It's having all of that full OSPF conversation. And then what this, after that, after the slash, is what is that device configured at on the far end. If you would see this, it would say that it's the D other. Once again, the DR other means it's not a designated router, it's not a backup designated router. So it's not a designated router, it's just another device running OSPF on my network. So the command they want us to enter is show IP OSPF neighbor. I'm going to go ahead and start that on RA, router A. I open it up. I make the window a little bit bigger going right and left. I find that helps format it out. And then I click on the CLI tab. You can see the CLI tab in the upper left corner. Go ahead and click on it. You can hit enter. No passwords. I can go ahead and type enable, get into privilege exec mode. From here's where I can go ahead and enter in my command. The command once again is show space IP space OSPF space neighbor. And that'll list out all of my neighbors I've learned through OSPF. First one right here is 192.168.31.22. If we look at our topology over here, here is 192.168.31.22. Last octet here is .22. What that signifies is that we're on router B. B is 2. You're going to get that connection here pretty soon. And if we look over here, the last octet is .33, and that's on router C. And then router A, the last octet is 11 or 1s. So A is 1, B is 2, C is 3. Coming back and looking at our neighbor table, we can see that 192.168.31.22 is one of our neighbors. We've formed an adjacency with it. The state is full BDR. What that means is we are on router A right here. We are on router A, and that connection up to 192.168.31.22 or router B, we have full OSPF communications, and that FAR device is identifying itself as the BDR, the backup designated router. And now we can look at the second entry. The second entry has the IP address of 192.168.31.33. That's right here on router C. We have full communication, full OSPF communication with it, and then that the FAR device is identifying itself as the DR, the designated router. Let's go ahead and minimize that. Let's go ahead and look at router B quick. Router B, make that a little bit bigger. Click on our CLI tab up here, hit enter. User exec mode, go ahead and type enable. Brings us into privileged exec mode. From here, we can type our command, show IP OSPF neighbors, or neighbor, and it'll list out the neighbors. I'm going to slide this over here. Once again, we are on router B up here. Router B has formed an adjacency with 192.168.31.11. That's router A down here on the bottom left. It has full OSPF communication, so it's sending all of those files, updates, link state announcements to router A back and forth. And then that FAR device, router A is identifying itself as a DR other, a designated router other. It's not a designated router. It's not a backup designated router. So it's just another router on our network running OSPF. The second entry here, 192.168.31.33 is router C here. We have full OSPF communications with it, and that FAR device, router C, is identifying it as a DR, the designated router. Let's go ahead and quickly look at RC. Once again, I click on the CLI, make the window a little bit bigger. Hit enter. Oh, let's click in the window. There we go. Type enable. Now the command was show IP OSPF neighbor. And we have two entries. Two entries again. Once again, we are router C right here in the bottom right. First entry is 192.168.31.22. That's router B. With router B, we have full OSPF communications. And that FAR device is identifying itself as the backup designated controller. Second entry is 192.168.31.11. That's router A over here on the bottom left. We have full OSPF communication with that. And that FAR device is identifying itself once again as a druther, a DR other, not a designated router, not a backup designated router, just another router on our network running OSPF. Which router is the designated router? So I'm going to open up router A again. We're looking for a device that's identifying itself as the DR. That would be this device. Once again, this says we have full OSPF communication with it, and the FAR side is establishing itself as the designated router. The IP address is 192.168.31.33. That is router C. So router C is our designated router. Answer to our question is router C or RC. Then the next question, which router is the backup designated router? Seeing as I have the router A window here, I am looking for one that's identifying itself as the BDR. Right here is that record. We have full OSPF communication with it, and that far device is identifying itself as the BDR, the backup designated router. That IP address is 192.168.31.22. Once again, that is router B. So router B is our backup designated router. And so answer here is router C. No, sorry, router B. Router B, it was the top one. Last one. What is the OSPF state of router A? Well, a couple ways to look at that. We can look right here. We are on router A. We've identified a device as the designated router and the backup designated router. Seeing as there can only be one of each, that means that any other devices is the druther. So we are on A, that identifies us as a druther. Or let's go ahead and minimize this, open up router B, look at its information from the show IP OSPF neighbor, and here we have full OSPF communications, and that far device is identifying it as a DR other, not a designated router, not a backup designated router. And that IP address is 192.168.31.11, which is router A. And our question is, what is the OSPF state of router A? Find router A here, see what it's identifying itself as, a DR other. It is DR other. Step 3, turn on IP OSPF adjacency debugging. Debugging is when you get extra commands. There's a lot of commands, a lot of processes happen behind the scenes where you don't get output on the screen. Debugging can turn those processes into giving you output on the screen, and that's what we're going to do. We're going to say we want to see all the debug statements. We want to see any statement that has to do with IP OSP adjacencies. I'm going to go ahead, open up our A here, router A, hit enter a couple of times, and then we're going to go ahead and turn that on. So it's debug space IP space OSPF ADJ for adjacencies. So anything that has to do with OSPF adjacencies, we're going to get printed out to our screen. I get a system update message saying event debugging has been turned on. I like to hit enter several times just to give me an area to identify. I hit enter several times, so anything that pops up after this is new. Now let's go ahead and turn that on B here quickly. Once again, command is debug space IP space OSPF space ADJ for adjacency. Turns it on. I hit enter a bunch of times. That turned on OSPF adjacency debugging for step 3. On to step 4. Step 4, disable the gig 00 interface on RC. Use the shutdown command to disable that link. Now remember, router C was our designated router. We're going to disconnect it from the network. Then we're going to see what happens over here. I'm going to connect into router C. Get into global configuration mode. Go into the interface of G0/0. And then I'm going to disable it by using the command shutdown. That brings the interface down. It brings the line protocol down. Then we get some adjacency changes saying we have now, with the adjacency to neighbor 192.168.31.22, router B, we have now went from full to down. Also, with the neighbor adjacency of 192.168.31.11, router A, we have now went from full to down. Okay, wait for 30 seconds for the dead timers to expire on RA and RB. According to the debug output, which router was elected designated router and which router was elected backup designated router. Let's go ahead and take a look at A. Look at all this output. Now, this is why I hit enter several times. I hit enter several times so I could scroll up here and easily identify where the new messages started. As we look here, we can see that we have a neighbor adjacency problem on 33. We went from full to down. Then we start sending out some link state advertisements for router A. We start looking at doing an election process and sending out more link state announcements. And finally down here, we come to the end of the election results. At the end of our election, designated router has been turned into 192.168.31.22, which is now router B, and then our backup turned into router A. Now, in actuality, router B wasn't necessarily elected the backup designated router. What happened is it got designated router. It got promoted from backup designated router to designated router. So the process change to go from a backup designated router to designated router is not an election process. It's when the designated router fails, backup gets promoted to the designated router. Okay, which router was elected designated router? Designated router was the one ending in .22 or router B. So designated router is now router B. And then the backup designated router, 192.168.31.11.11, which was router A. So the backup designated router is now router A. I hope you're liking this episode on practical configuration examples. Leave a comment on what you think about these configuration examples. If you still have a question or comment, please let me know below. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Okay, on to step 5. Restore the Gigabit Ethernet 00 interface on RC0. Wait for the new DR BDR elections to occur. Let's go ahead back to RC here. So minimize this window, click on RC. I hit enter a couple of times. What I'm going to do is I'm also going to go on RA. I'm going to hit enter several times so it gives me a nice area to see the new messages that pop up. I'm going to do the same thing on B. Now on C, to disable it, we type shutdown. To enable it, we type no shutdown. Those interfaces will come up. When they come up, we'll also get some link state updates. But let's go ahead and take a look and see what's happening for the election processes. Now, we still got this amber light here saying we have the negotiation. We can click the fast forward button down here. I'm going to go ahead and do that. I actually clicked it a couple of times. Let's go ahead and take a look at router A, see what happens. We're going to scroll up here. Scroll up. This is where I hit enter the last time. So that way we can see. Now, we can see that we have the selection. We're going through the process. Sending some database updates. We're asking for some link state updates. We're receiving different information. And then down here we have finally the ending result of our election. The designated router is 22, which is router B. Well, that's what we just had up here in step 4, but we're on step 5. And then the backup designated router is router A. So it didn't change. The roles did not change when that came back on. So no, it didn't. Why didn't it? The only time that election happens and a backup gets promoted to the designated router, or we get a new backup designated router, is when one of those two goes down. And if we think about it, when we disconnected this over here, that took our designated router away on C. So they went through, they promoted router B to the designated router. Router A got the backup designated router. And so they were happy doing that. Router C, we re-enabled that connection, brought it online, but the designated router, backup designated router never changed. So we didn't have to go through the election process to change anything. That is why it stayed the same. And so no, because OSPF does not update the DR/BDR when the existing one are active. Let's spell existing right. Verify the DR and BDR assignments using the show IP OSPF neighbor command on RC. Let's go ahead and minimize this. Open up RC. Hit enter several times. Type exit to get out of the interface configuration mode. Type exit a second time to get out of global configuration mode into privilege exec. We can now enter in our command. So show IP OSPF neighbor. And there is our connections. It's showing us that the device 192.168.31.22 router B is our designated router. And once again, here underneath the state, we have full OSPF communication. So we're sending all LSAs and everything to this association, and that FAR device is identifying it as the designated router. And then the next entry here is for router A, and that identifies it as the backup designated router. Step 6, disable the gigabit Ethernet 00 interface on RB. We're going to go through and disable that one. Right now, currently RB is our designated router. RA is our backup designated router. We're going to take RB out. We're going to take out our designated router. So I'll go over here, click here, hit enter several times. Actually, what I'm going to do is I'm going to make sure I go to RA, hit enter several times to give me some clean area so I can see where the break is. Do the same thing with RC here. Now back on RA, we're going to disable the gig 00 interface. So I can go ahead and type config T, get into global configuration mode, get into the interface. So interface gig 0/0. And from here we can disable it. Disable it by typing shutdown. It takes it down. We can see we get some messages, some debug messages saying, okay, the interface went down, line protocol went down, but now we have some neighbor adjacencies. Our adjacency to router A has went from full to down because that interface is there. Our adjacency to router C has went from full to down because that interface has went down. It tries to do an election process, but it soon realizes that it's the only one on that network. Let's go ahead and take a look at router A. See what it looks like. I'm going to scroll back up to router A here, where we hit enter several times. So this is where we did that before that, and now we can see here. Dead timer has expired for router B. Saying we can't reach that anymore. We're going to take that from full communications and mark it as a down. Then we're going to start sending some link state updates. Now we're going to start going through the election process. We go through the election process. We send some link state updates. Once again, we verify our election. And now our final results here are the designated router has now become router A, and the backup designated router has become router C. So according to the debug output on router A, which router was elected DR and which router was elected backup domain router? And once again, we can get that from that last line right here. The designated router is now 192.168.31.11, or also known as router A. And the backup designated router is now, I spell now correctly. The backup designated router is 192.168.31.33, or also known as router C. Router C. Restore the gig interface on router B. So I'm going to come up here, click on router B, hit enter several times. Still in that interface. So we type shutdown to disable it. We type no shutdown to enable it. So no space shutdown. That re-enables it. Our interface has now went to up. Our line state has now changed state to up. We are starting to build our routing table. Let's give it some time. What I'm going to do is I'm going to click the fast forward button a couple times. Here, router B, we can see that the processes went through. Scrolling all the way up, we can see that we went through the election. We passed some information through LSAs. We passed some database information between the devices. Coming down. And let's scroll back up to the last election. Here, the last election, designated router still stayed on router A, backup designated router stayed on router B. Question is, wait for the new DR BDR elections to occur. Did the DR and BDR roles change? According to router B, they haven't. Let's go ahead and check router A quickly. Scroll back up to see our last election right here. Designated router is router A. That's what it was right up here in step 6. Our backup designated router was router C. That's what it was. No, the roles did not change. And so no, and the reason they didn't change is because the current designated router and backup designated router did not lose connectivity. They are still active. Use the show IP OSPF neighbor command on router C. What is the status of router C now? Okay, let's go to router C. Hit enter a couple of times. The command we want here in privilege exec mode is show IP OSPF interface. What is the status of router C now? Type your answer here. We're looking in here for the OSPF status. And as we can see, we got lots of information. We got process ID, router ID, network type is broadcast. Next line, third line down here is the transmit and delay, but our state is BDR. So router C is the BDR. Turn off debugging. Enter the command undebug all on router A and router B. Okay, let's go ahead and do that. So undebug. And now you could do just the OSPF adjacency we are looking for, or if you just want to turn off everything, just use the undebug all. It turns off all possible debugging. I'm going to go ahead and do that on router B quickly. Exit out of the interface, exit out of global configuration mode. Now I can do undebug all. On to part 2. Modify OSPF priority and force elections. We're going to go ahead and modify the priority. Where we're going to do that here is on router A. So we're going to change the designated router and backup designated router using the IP OSPF priority command. On Gigabit Ethernet 0 on each of the routers with the following OSPF priorities. And so router A, we're going to set with a priority of 200. Router B, we're going to set with a priority of 100. Our C should be already set to 1, but we're going to go ahead and do that. Just set it to make sure it's there, because 1 is the default priority. If you don't set it, it has a priority of 1. Let's go ahead and click on router A. From router A, we have to go into the interface. So first thing I have to do is go into global configuration mode. Then I have to go into the interface of gig 0/0. Now we can go ahead and set that priority. Command here is IP, because we're dealing with the IP suite. Then it's OSPF because it's part of the OSPF routing protocol. And now we will set the priority by putting priority. And then we want 200 as our priority. So the command, now that we're in the interface, is IP space OSPF space priority space 200. It sets the priority at 200. Let's go ahead and do router B and C. Router B here. Config T for global configuration mode. Interface gig 0/0. And we can set the priority. So it's IP space OSPF priority. And then for router B, we are setting it to 100. And then let's go ahead and do router C. Config T, interface gig 0/0, IP, OSPF, priority, and we want to set it as 1 for router C. Okay, we set the priorities. Step 2, force an election by resetting the OSPF process on the routers. Starting with router A, issue the clear IP OSPF process on each router to reset the OSPF process. So we have to go to each router and type in clear IP OSPF process. That'll reforce the election. So starting on router A. In privilege exec mode, so I have to type exit twice. Clear IP OSPF process. Now it's going to say, are you sure you want to do it? Yes, I am. So you have to type the word yes and hit enter. And now you can see we are doing a whole lot of changes to our adjacencies. Let's go ahead and do router B quick. Exit to privilege exec mode. Clear IP OSPF process. Type in yes because we want it to go. Does that, and let's go ahead and do router C right away. Type exit twice, and then clear IP OSPF processes. Yes, I'm sure I want to do that. And it went through and did that. Now, this could take a little bit. This could take several minutes for everything to get done. Now, what we can do is we can go ahead and click the fast forward time button. Down here in the bottom left, the 2 little triangles pointing to the right, that's fast forward. I'm going to go ahead and click that once, twice, 3, 4 times just for good luck. According to the output from the show IPS OSPF neighbor command in the routers, which router is now the designated router and which router is now the backup designated router. Let's go ahead on router 1. Hit enter. Notice we don't get any of that election information because we turned off all that debug information for the OSPF adjacencies. We don't get any elections or LSA being passed back and forth. But let's go ahead and enter that command in. Show IP OSPF neighbor. From this command, first entry 192.168.33, which is router C. We have full OSPF communication with it, and that far device, router C, is identifying it as a DR other, not a designated router, not a backup designated router. The next entry, 192.168.31.22, that's router B. We have full communications with it, and notice we have a priority of 100. That's what we manually entered in. We have full OSPF communications with it, and that far device is identifying it as a backup designated router. Well, we have 3 devices. One is identifying it as a DR other, another is identifying it as a backup designated router. That means the device we're on should be the designated router. Well, let's go ahead and minimize this. Let's go ahead and run that command here on router B, just to confirm. And once again, that command here was show IP OSPF neighbor. First entry 192.168.31.11. That was router A. It has a priority of 200. We manually set that. Highest priority gets to be the designated router when we do a clean election. And so the state here is we have full OSPF communication with it, and that FAR device, router A, is identifying itself as the designated router. Router A is identifying itself as the designated router. Next entry, 192.168.31.33. Router C is identifying it as itself as a DR other. Let's go ahead and just run it on RC, router C. Show IP OSPF neighbor. And here we have 192.168.31.22, which is router B, identifying itself as the backup designated router. And next entry, 192.168.31.11, is identifying itself as the designated router. So right here, it's listing it. We're on router C, which is none of them. That's the DR other, but the other two devices we can identify. So we have to answer the question. Designated router is now router A, and backup designated router is now, right? Yep, router B. If the routers do not elect the correct designated router, backup designated router after setting the OSPF priorities, try restarting Packet Tracer. Sometimes you might have to save it and reset it. The other thing I found was you didn't necessarily do the clear, right here, the clear IP OSPF command close enough on all three devices. Try going back and doing those as quick as you can. Okay, that was Packet Tracer Lab 2.3.11. Determine the designated router and backup designated router. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.